Now we're looking at number 13. If x is greater than 3, which of the following is equivalent to this pretty nasty fraction here? 1 over x plus 2 plus 1 over x plus 3. So there are kind of see two different ways to kind of approach this question. We could either do just the good old algebra way, which I'll do in a bit, or you could do another way where, if you look at this condition, if x is greater than 3. So what that says is, if we plug in some value of x greater than 3, let's just say 4. If we plug it into this part, if we were to plug in x equals 4 to one of these answers, we would have the same choice. Now, that's a freedom given to you of if you're better at plugging in numbers than doing manipulation in algebra, I suggest you go for that. Maybe you're opposite. Maybe you're better with manipulating variables than plugging in numbers. Because remember, you don't have a calculator here. Regardless, you do where you're comfortable. I'll show both ways. So I'm going to get a new page here real quick. Perfect. I just rewrote the equation 1 over x plus 2 plus 1 over x plus 3. So the way we kind of deal with this normally in math, we don't like fractions or generals, and we don't like it when we have fractions and a fraction itself. The key thing here is to get rid of the fraction. So what I'm going to do first is I want to get rid of this 1 over x plus 2 plus 1 over x plus 3. Now don't freak out. Just because it says 1 over x plus 2 plus 1 over x plus 3, we can add these fractions. So let me do a numerical example, and then I'll come back to this one. If I have 2/3 plus, let's say, 4/5. If I want to add these fractions, obviously I would get a common denominator. So it looks like 15 would be the best number here. So I would multiply everything here by 5. So I'll do 5 over 5. And everything here by 3. We'll end up getting 10 over 15 plus 12 over 15. So notice what I did here. I multiplied this 4/5 by 3, which is a number in my denominator. I multiplied everything in this 2/3 by 5, which is a number in my denominator here. What does that tell us? Well, we do the same thing with expressions like this. I'm going to do the scratch work right here. 1 over x plus 2 plus 1 over x plus 3. I will multiply everything here by my denominator of my other fraction, which is x plus 3. Same thing for this fraction here. Multiply everything by x plus 2. What does that give us? Well, we just got to work it out. And I'll get a pretty line over here. So x plus 3 plus times 1. That would just be x plus 3. And I'll write it up here. Now, x plus 3 times x plus 2. I'm going to rewrite it like this. I am not actually going to FOIL this out. I could, if I wanted to. However, in this equation, let's not do that just yet. So what do we have next? Okay, x plus 2 times 1. That's obviously just x plus 2. And then we have x plus 2 times x plus 3. Again, just leave it as x plus 3 times x plus 2. Awesome. Just like we add fractions, get a common denominator. Once we get a common denominator, adding fractions, we keep the denominator the same and just add the tops. So our new really absurd fraction would now be 1 over x plus 3 plus x plus 2. Just add your numerators and you keep your denominator the same. X plus 3, x plus 2. So it's still kind of terrible, but it's not as bad as it was originally. But if we were to look back at our answer choices, that's still not an answer choice. Notice it's just in one fraction itself. So we still need to get rid of the fraction in my numerator, or in our denominator. So how do we do that? Again, let's do a numerical example. if I was to do, let's say, 1 over, I don't know, 8 sevenths. So this is 1 over 8 sevenths. And when to get rid of fractions denominators, if you're dividing by a fraction, that is equivalent to multiplying by its reciprocal. So how does it look like practically? This 1 over 8 over 7 is the exact same thing as 1 times 7 over 8. Instead of dividing by a fraction here, I can just multiply by its reciprocal. And so, and also, that's just 7 over 8. So notice you just kind of flip the bottom. How does it look like for this big equation here? Well, we do the same thing. Instead of dividing by this huge fraction in my denominator, I'm just going to multiply by its reciprocal. 1 times the reciprocal of x plus 3, x plus 2, x plus 3, x plus 2. It would be, well, first, I'll just write it like this. Oh, I apologize. I did the exact opposite of what I said to do by its reciprocal. So I'll flip the fraction. X plus 3, x plus 2. And my bottom, I'm going to go ahead and do another step here. I'm going to combine my like terms. So x plus x, that would give us 2x. And then 3 plus 2 would be 5. And 1 times that, well, that's just x plus 3, x plus 2. So, sweet. We got rid of this huge fraction here by just multiplying by the reciprocal. The reciprocal is you just flip the fraction. So we end up getting x plus 3 times x plus 2 over 2x plus 5. And that's not it. Still not our answer choice. But we're closer. We know it can't be C or D now. So let's go ahead and multiply this out. Remember, when you're multiplying two binomials, your binomial is your top two terms on top here, you do this thing called FOIL. FOIL. What does that do for us? You multiply some people say first, some people say front. I'm going to say first. Same thing, some people say out, some people say outside, or outer. Then our inside. Then our last. How does it look like? Our first two numbers, so x times x, that is x squared. Our outer numbers, x times 2, that would be 2x. Inner numbers, or the inside numbers, 3 times x, that would be 3x. And then our last two numbers, 3 times 2 would be 6. Now we can just combine like terms here. And I'll keep my denominator here. And I'm going to erase this original question. And I'm going to write my answer back up top. X squared, combine 2x plus 3x, that'd be 5x. And then add a 6. And then keep our denominator the same, which will give us an answer choice B. X squared plus 5x plus 6 over 2x plus 5. Again, that's one method to do it. Another method, if you're really good with plugging in numbers, I can plug in some number where x is greater than 3. So in this case, let's just say when x equals 4. I can plug in that number to my top equation, and to my original equation, I apologize, and plug in that number to each individual answer choice as well. Saves you for having to do the algebra, but you gotta do math instead. So how does it look like? If I plug in x equals 4 to my original equation, I'll have 1 over 4 plus 2 plus 1 over 4 plus 3. That is now, I'll write this here, 1 over 6 plus 1 over 7. So same concept as we did before, add the two fractions. So that would end up being 1 over, let's see, that is 7 over 42 plus 6 over 42. And then that is 1 over 13 over 42. And again, when dividing by a fraction, just multiply by its reciprocal. Instead of saying 1 over 13 over 42, I will now say 1 times 42 over 13. So what does that mean for us now? If I plug in 4 to any one of my 4 answer choices, and I also get an answer of 42 over 13, then those two must be equivalent. So how does that help us? Well, we know it can't be C and D, and we can also just plug in here. So if I was to plug in x equals 4, I actually already had that written there. If I was to plug x equals 4 to either answer choice A, well, we'll see that the top is going to be 13. So that can't be it. So, and the bottom would be 42. So answer choice for A would be 13 over 42, which we want is reciprocal. So plug in x squared plus 5x plus 6 over 2x plus 5. We plug in 4 here. Oh, well, we already did that, so that'll be 4 squared plus 5 times 4 plus 6 over 2, 4 plus 6. That's a 4 there, by the way. 4 squared plus 20. So that'll be, so that's 16 plus 20, which is 36. And add 6 will be 42. And then 2 times 4 is 8. Oh, yeah, and then 8 plus, that should be a 5. That's y. So that's 8 plus 5. That'd be 13. So looks like answer choice B is correct. Again, either one of the two methods work. Either do the long, not drawn out algebra way, or could have just plugged in some value of x that is greater than 3. In this case, I just chose the smallest number I could, which was 4. That was accessible to us, and it worked. Either way, either method, you still get an answer choice of B.